Hi class! Today as we go into section 5.2, the graph of the polynomial function, I just want to remind you that we had a section 5.1 which talked about all the properties of polynomial functions. And as we talked about all those different properties, I did bring up the graph a lot. All of that stuff was presented in section 5.1. So make sure that you watch that video first and that you understand what each of those pieces are. And then we're going to put it all together to create the graph today. I'll be recalling some items from that previous lecture as we go through question number 1. So question number 1 says to follow the steps that were previously shown to graph the polynomial functions. And one of the things that we need to do is to determine what degree this function is. So even though it's written in factored form, which we prefer, we're going to multiply it out in our heads. Say this is x to the first power and x to the third power. That would mean that the degree is a 4th degree polynomial. It's really important to know that it's a 4th degree polynomial because that really helps us answer step 1, which tells us to determine the end behavior of the graph of the function. Now because we have a 4th degree polynomial, we're looking at our graph of even power functions. And you should notice that the arms either both go up or both go down. In this graph that we have, all of the arms go up, but that's because all of the coefficients are positive. And so because our coefficient is -1/2, both of our legs are actually going to turn and go upside down. So the negative will do this to it. And we're looking at the endpoint, so we're just looking at those two endpoints going down to -infinity. Therefore, if I was looking at the graph function, I'm thinking about the endpoints going to -infinity. Moving on to step 2, we're going to find the x and the y-intercepts of the graph of the function. Now we're going to do the y-intercept first because that's a little bit easier to do. And you're just going to substitute x for 0 and then simplify for the y value. To find the x-intercepts, we're going to replace y with 0. In other words, we're going to replace the f of x with 0. And then you would solve by factoring. But this function is already factored, which is nice. So we're just going to do that and use a zero product property to set each of those factors equal to 0. Now for the y-intercept, we're going to replace x with 0. So I'm just going to write f of 0 is equal to -1/2, 0 plus 4, and 0 minus 1 cubed. After we plug it in and simplify, we get the value of 2. So I know that my point is 0, 2. I'm going to put that over here on the graph. Now to find the x-intercepts, I'm going to take f of x and set it equal to 0. So I'm going to get 0 is equal to -1/2 x plus 4 times x minus 1 cubed. And now I need to put each factor equal to 0, but only the factors that have variables, because it makes no sense to say -1/2 is equal to 0. So we're just going to take the factors x plus 4 is equal to 0, and the other factor x minus 1 cubed is equal to 0. And that actually gets simplified to x minus 1 is equal to 0 if I took the cube root of both sides. Now each of these is very easy to solve, and I would get -4, 0 and 1, 0 as my x-intercepts. Let's put that on the graph. And I get at -4 and at 1, I get my x-intercepts. Step 3 asks us to determine the real zeros of the function and their multiplicity. But recall that the real zeros of a function are the same thing as an x-intercepts. And so we've already found the x-intercepts, so half the work is done for us. And all we need to do is determine if the multiplicity is even or odd. So when I'm looking at this function, I see that I have x plus 4 to the first power and x minus 1 to the third power. Those are both odd, so they're both going to cross the x-axis at each x-intercept. Since I know I'm going to cross at each x-intercept, I can do that, but I also know because the end behavior is going down to negative infinity, then I'm going to be below the x-axis outside of at the ends of the graphs. So I do know that as it's going to come through the negative 4, and it's going to go through the positive 1, but the end behavior is going to go down, like I sketched earlier. Now, step 4 asks us to determine the maximum number of turning points on the graph of this function. Because this is a 4th degree polynomial, we're going to have a maximum of 3 turning points. We don't necessarily know where any of them are, we just know that we have a maximum of 3. And that's just something to keep in mind as we're drawing the graph. Now there's a lot of different ways that could play out. So one of the ways that could happen is that all of those turning points are above the x-axis, or potentially I could have one of them down here, then go through that and come back, or maybe I could have it happen on the other side. So it could be going through the 4, the 2, the 1, and then having a turning point there. We really don't know. We just know that we have a maximum of 3, and it might not even have all 3. It might just have 1 turning point. But we do know that we have possibilities. Now step 5 asks us to use the information in steps 1 through 4 to draw a complete graph of the function. And we see that we have sort of a sketch going on this right hand side, but we don't know where any local or absolute max or min are. We don't really have an idea of what the graph does in the middle. So I'm going to plug in a few points, maybe to help us figure out what this graph should actually look like. And I think I see that I have a coefficient of -1/2, so I want to plug in points that are going to make it easy to divide by 2. So I'm going to plug in my value of -2. And wow, I get the point -227, so that's going to be way up here somewhere. And so I'm going to have a graph that goes all the way up there, it's going to come back down, and then do something over here. I went ahead and plugged in x is equal to -3 to see what happens, and that point is even higher at -332. So I'm going to draw my graph going down through -4 as my x-intercept, and then coming down through 27 with a y-intercept of 2, and maybe something going on over here, going through both of my y-intercepts. Now that might not be the most accurate graph, but it does hit a lot of the values, and we want to be sure that when we graph it, we're very accurate at going through our x-intercepts, our y-intercepts, and any points that we found out. The shape might be slightly different from the actual graph, but as long as you hit those values that you discovered, we're going to call it a good sketch. Now comparing the graph that we sketched to the actual graph of this function, we can see that we did a fairly good job. We have our x-intercepts down, we have our y-intercept down, we have the height of the function, we have the end behavior of the function. We do have a little bit of the curvature weird right around the origin, but overall we did a great job of getting the graph by using all the different properties that we learned in section 5.1. So good job to us. We're going to graph question number 2 by using the same steps 1 through 5 like we did before. So the first step was to determine the end behavior of the function, and the way we do that is by checking out the degree. It's very easy to see that this is a 3rd degree polynomial, so let's look at our odd power functions. And looking at our odd power functions, we can see that one leg goes up and one leg goes down. Typically, the one going to positive infinity on the x-axis will go up to positive infinity, and when we're going down to the negative infinity on the x-axis, we'd go down to negative infinity on the y as well. This is when our coefficient is positive, which is what we have. We have a positive 4 as our leading coefficient. Now if our leading coefficient was negative, we would flip these, and so it would go the other direction. but we're going to go ahead and use this as our guide. For step 2, we want to find the x and the y intercepts of the graph. Before we do that, I want to factor it so that we can find the x-intercepts easier. And this has 4 terms, so I'm going to factor by grouping. Keep in mind that that negative in the middle is going to be grouped into the second parentheses. And so I have to put a plus sign in between my parentheses and drag that negative in. That way I can factor it better. And I know I've done a good job factoring if each of the parts in the parentheses match up. And so that means I can collect their coefficients. And so I'm going to get f of x is equal to 2x squared minus 2 and 2x plus 5. And I just noticed that there is a GCF in here. So I'm going to factor that out one more time. Oh, and now that I've done that, I noticed that that's a difference of squares, so I know how to factor that. I'm going to get x plus 1, x minus 1, and 2x plus 5. And so now I'm ready to find all of the x-intercepts and the y-intercepts. To find my x-intercepts, I'm going to set my function equal to 0, and then I'm going to apply the zero product property to take all of the factors that have variables in it and set each of those factors equal to 0. Remember, I don't have to put that 2 equal to 0 because 2 is not equal to 0. But I'm going to get negative 1, positive 1, and negative 5/2. Which I like fractions, but to be able to graph it, we need to know that it's negative 2.5. To get my y-intercept, we're going to plug in x equals 0. That means all of these terms become 0, except for the constant at the end. So that's really easy to see that I get 0, negative 10 as my y-intercept. So let's put that on the graph. I have a y-intercept at negative 10, and I have an x-intercept at negative 1, another one at 1, and then one at negative 2.5. To be able to do step 3, we want to determine the multiplicities of the real zeros. Keep in mind that the real zeros are the same thing as the x-intercepts. So we're just going to go over here to the function as it's factored. We're going to look at it, the powers that they have. Each of these factors have a power of 1. So that means that's an odd multiplicity. So each of these have an odd multiplicity. The graph is going to go through each of the x-intercepts. It's going to cross the x-axis. So it's going to cross through, go through the y-intercept, and then cross through again. Something like that. Now, I don't know what the scale is, but that's the basic shape of it. Step 4 asks us to determine the maximum number of turning points on the graph. And because it is a third-degree polynomial, we're going to say it has a maximum of 2 turning points. And we can see that on the graph. We see the one turning point right here and another turning point right here. And so we know we have the basic shape correct. Now step 5 asks us to find additional points on the graph to see if we can help this graph get to the right values. And we have 3 x-intercepts, negative 2.5, negative 1, and 1. We already have the y-intercept, which is a point in between the negative 1 and 1. So I'm going to go ahead and plug in negative 2 as another point in between the other 2 intercepts. And I have a choice. I could plug into my original function, which is the 4x cubed plus blah blah blah, or I can plug it into the factored function, and that's the one I actually like to plug it into better. It's a little bit easier for me to simplify these pieces than to try to come up with negative 2 to the 3rd power and other things like that. And so there we have it. We have another point, which is negative 2, 6. So we just need to make sure that this value right here, that is height, goes through at 6. So I'm just going to draw a better sketch of this graph. Notice that my x-axis and my y-axis are different scales. That's okay. Let's go ahead and put my negative 2.5, my negative 1, my positive 1, x-intercepts there. I'm going to put my y-intercept of negative 10, and I'm going to put that value of negative 2.6 over here. I'm just going to make sure I go through all of these values. And so there's my sketch of this graph. Let's look at Desmos and see how we did. And there's our official graph from Desmos, and it looks like we did a really good job again. Now question number 3 asks us to use a graphing utility to graph these polynomial functions. But I'm going to go ahead and go through steps 1 through 5 for a little bit extra practice, and then we'll just check it with the graphing calculator at the very end. And so the first thing we want to do is determine the end behavior. I want to learn that this is a 5th degree polynomial, and so that end behavior is going to, one leg is going to go up and one leg is going to go down. But my leading coefficient is a negative, and so it's not going to be the same as last time. I'm going to flip it. So it's going to go down to negative infinity, and it's going to go up to positive infinity on the other side. To be able to do step 2, I want to factor it first, and this is factorable. I do want to take out the negative 1 and also the x squared that I see in all the terms. And so I'm going to be left with x to the 3rd minus 5x squared minus 4x plus 20. And then we're going to factor by grouping again. Now, if you're going to do it like this, you do need an extra set of parentheses to keep this whole phrase together, because we have the negative x squared multiplied by everything. And then I'm just going to find my x-intercepts by setting this equal to 0. And you should get the x squared is equal to 0. The x plus 2 is equal to 0. The x minus 2 is equal to 0. And the x minus 5 is equal to 0. So we have 4 x-intercepts. One at 0, one at positive 2, one at positive 5, and one at negative 2. And then we want to find our y-intercept. So our y-intercept, we plug in x is equal to 0. I'm going to plug this into the original. And I'm going to get 0 plus 0 plus 0 plus 0. Oh, so my y-intercept is at 0. We've seen that already. So we have that there. And then for step 3, we want to know the multiplicity of each of these x-intercepts. Now, this is the only one with a multiplicity of 2. All the rest of them have a multiplicity of 1. So through all of them, through everything but the origin, it will cross. But at the origin, it will touch. So it's going to cross here at the 5, cross here at the 2, touch at the 0, and then cross through at the negative 2. And so this is sort of an idea of what it's going to look like. We're going to make it look a little bit better as we go through the steps. Step 4 says to determine the maximum number of turning points on the graph of the function. Because it's 5th degree, we have a max of 4 turning points. And I see 1, 2, 3, 4 already, so we've hit all of them. But we want to just make this a little bit better, so step 5 says to plug in some numbers to help us get a better idea of the scale. So now I'm going to plug in some points in between my x-intercepts. I've chosen the values negative 1, 1, and 3. I could have also chosen 4. Maybe I'll do that also, just how we get an idea of what this graph is going to look like. So I plugged in these x values that we've chosen in between our x-intercepts, and you can see their values. I get -18, -1, -18, 1, -12, but then I also get 3, 90, and 4, 192. So the scale of this is going to be quite large. Let me go ahead and try my best at sketching a graph. Let me try my best at sketching a graph. We're going to start by putting all of our x-intercepts back onto this graph. I have one at 0, one at 2, one at 5, and one at -2. I also have a y-intercept at 0, so that's already on the graph. I'm going to put on the points -1, -18, just sort of approximating where their values are. +1, -12, 3, 90, and 4, 192. And then I'm going to connect this. I'm going to start right around here, touch at 0, go through at 2, hitting all these points that I've discovered, going through at the 5, and going through at the -2. So this is sort of my idea of how the graph goes. Let's compare our sketch to the actual graph. And you can see that our sketch was a pretty good graph, an idea of the graph. Here's the official graph from Desmos.com. We have all of our intercepts correct. We have the maximum turning points correct. We have the shape of it and the heights and the lows of it correct. And we did a pretty good job. So once again, all of these properties that we've been practicing, it's in section 5.1 and 5.2. You really need to get good at that before we move on to the rest of the chapter. Thank you. Have a good day.